Have you ever wondered why graphics cards are becoming harder to find, or why their prices keep increasing over time? What used to be a simple component mainly used for gaming has now become something much more important in today's world. And the reason behind this change is artificial intelligence, along with the growing demand for computing power. Today, AI systems are capable of generating images, writing text, analyzing data, and performing complex tasks in real time. These systems are becoming more advanced every day, expanding into more areas of technology and daily life. But behind all of these capabilities, there is one key element that makes everything possible. And that element is raw computational power, which is required to run and train these systems. Without that power, none of these advanced AI technologies would be able to function at the level we see today. To understand why this matters, we need to take a closer look at how modern artificial intelligence actually works. Unlike traditional software, AI systems are trained using extremely large datasets, learning patterns through repeated calculations. These calculations are not simple, and they are not performed just once, but millions or even billions of times. This process requires hardware that can handle many operations simultaneously, efficiently, and at scale. And this is exactly where graphics cards, also known as GPUs, come into play. Originally designed to process images and graphics, GPUs are uniquely suited for parallel computation. Which means they can perform thousands of calculations at the same time, much faster than traditional processors. And this is what makes them essential for training and running modern AI systems. Artificial intelligence systems rely on complex neural networks that process information across multiple layers, allowing them to learn from data. These networks are designed to recognize patterns, make predictions, and improve their performance over time through continuous training. As data moves through these layers, the system adjusts internal parameters to become more accurate and efficient. This process involves an enormous number of calculations happening simultaneously at a very large scale. And as AI models become more advanced, the complexity and volume of these calculations increase significantly. Traditional processors, or CPUs, are not optimized to handle this level of parallel computation efficiently. They are designed for sequential tasks, processing one instruction at a time in a controlled and linear way. Which makes them less suitable for the massive workloads required by modern artificial intelligence. This is where GPUs begin to play a critical role in the development of artificial intelligence systems. Unlike CPUs, GPUs are designed to handle thousands of operations at the same time through parallel processing. This allows them to process large amounts of data much faster and more efficiently than traditional processors. As a result, GPUs have become the standard hardware used for training modern AI models. Over the past few years, the use of artificial intelligence has expanded rapidly across multiple industries. From healthcare and finance to content creation and automation, its impact continues to grow. And with each new advancement, the demand for computing power keeps increasing even further. Which is why the need for GPUs has grown so quickly in recent years. In some cases, a single AI company can require tens of thousands of GPUs just to train one advanced artificial intelligence model, making these systems incredibly demanding in terms of hardware. These models are not trained in minutes or hours, but over days or even weeks of continuous computation, running non-stop across massive computing systems. During that time, thousands of GPUs work together simultaneously, processing enormous amounts of data in parallel to accelerate the learning process. This requires building what are known as GPU clusters, where many machines are connected into a single powerful system capable of handling extreme workloads. And as these AI models continue to grow in size and complexity, the amount of hardware required increases significantly with each new generation. This has created a situation where companies are competing to secure as many GPUs as possible, often placing massive orders in advance. In some cases, entire production batches of GPUs are already reserved before they even reach the consumer market. And this is one of the key reasons why availability for regular users has started to become more limited over time. At this point, you might think the solution is simple, that companies can just produce more GPUs to meet the growing demand. But the reality is far more complex, and producing advanced hardware is not something that can be scaled quickly or easily. Modern GPUs are built using highly advanced semiconductor processes that require years of research, development, and specialized technology. These chips are manufactured in facilities known as fabs, which are among the most complex and expensive factories ever created. Building a single one of these facilities can take several years and cost tens of billions of dollars before it becomes fully operational. And even after production begins, manufacturing these chips involves extremely precise processes at a microscopic scale. This means that production capacity cannot be increased rapidly, no matter how much demand continues to grow. And this growing gap between supply and demand is exactly what is driving the current shortage of GPUs. As demand for GPUs continues to rise, the effects of this shortage are already becoming visible across the entire market, affecting both companies and everyday users. One of the most immediate consequences has been a steady increase in prices, especially for high-performance graphics cards that are now harder to access. In many cases, prices have climbed far beyond their original retail value, making these products significantly less affordable for most people. At the same time, availability has also been affected, with many high-end GPUs becoming increasingly difficult to find in traditional stores. This is partly because a large portion of the available supply is now being redirected toward large-scale AI infrastructure. Instead of reaching individual consumers, many of these units are being deployed directly into data centers around the world. As a result, individuals and small businesses are now competing against massive corporations for access to the same hardware. And in that kind of competition, companies with greater resources tend to have a clear advantage. But this situation goes far beyond rising prices or limited availability in the consumer market. Access to computing power is quickly becoming one of the most important resources in the modern world. Both governments and major technology companies are investing billions of dollars to secure access to advanced hardware. Because the more computing power you control, the more advanced artificial intelligence systems you can develop. And those systems are already being used across a wide range of industries, from business and research to security and strategic applications. This has created a new kind of technological race, centered around artificial intelligence and computing infrastructure. A race where access to GPUs and large-scale systems can determine who leads the next generation of technology. And in this race, having more computing power is no longer just an advantage, it is quickly becoming a necessity. As artificial intelligence continues to evolve, the demand for computing power shows no signs of slowing down, with systems becoming more complex and resource-intensive over time. Each new generation of AI models requires even more data, more processing, and more advanced infrastructure to operate efficiently. This continuous growth is pushing existing systems closer to their limits, forcing companies to expand their infrastructure at an unprecedented pace. New data centers are being built around the world, designed specifically to handle the increasing workload generated by modern AI systems. But even with this expansion, production capacity for advanced hardware remains limited, creating ongoing pressure across the entire supply chain. Manufacturing facilities are already operating at near maximum capacity, leaving little room for sudden increases in production. And as demand continues to grow faster than supply, the imbalance between the two is likely to persist. Which raises an important question: what happens if this demand keeps accelerating? Because despite all the challenges, the development of artificial intelligence is not slowing down, and neither is the need for more powerful hardware. Companies are continuing to invest heavily in infrastructure, research, and new manufacturing capabilities to meet future demand. New facilities are being built, new technologies are being developed, and systems are becoming more efficient over time. But these changes take time, and the gap between supply and demand cannot be closed overnight. For now, the industry is adapting as quickly as possible, balancing innovation with the limitations of physical production. And while progress is being made, the demand for computing power is still one of the defining challenges of modern technology. Because at its core, artificial intelligence is not just about software, it is about the hardware that makes it possible. And that hardware is becoming one of the most valuable resources in the world. Which brings us back to where we started. Graphics cards, once seen mainly as tools for gaming, have now become a central piece of global technological development. They are powering the systems that are shaping industries, driving innovation, and redefining what technology can do. And as artificial intelligence continues to expand, their importance will only continue to grow. Because in the end, the future of AI is not just determined by algorithms, but by the infrastructure that supports them. And that means the race for computing power is only just beginning. And what happens next may shape the future of technology for years to come.